and welcome to Prince Maths Clinic. Here we have a very interesting Olympiad question to solve, and the question says we should solve for a in a root of 9 plus the a root of 6 equals to the a root of 4. Now let's dive straight into the solution. Now we are going to divide all the terms here with the a root of 9. Therefore, I will have my a root of 9 divided by the a root of 9 plus the a root of 6 over the a root of 9 equal to the a root of 4 divided by the a root of 9. So all the terms here have been divided by the a root of 9. And I know that the a root of 9 cancels out the a root of 9. I will have 1. Then this is the a root of 6 over the a root of 9. So I'll give them a common a root. Then I'll put 6 over 9. I'll do the same thing here, give them a common a root. So this will be 4 over 9. Now, I can break this down by dividing both the numerator and denominator by 3. So 3 in 6 is 2. 3 in 9 is what? 3. So this becomes 1 plus the a root of 2 over 3. Now, this is the a root. I can write 4 to become 2 squared, and I can write 9 to be what? 3 squared. So it means that both the numerator and denominator have square on them. So now, going forward, I can now put 1 plus the a root of 2 over 3 equal to, now I want to rewrite this in a way that is still the same thing. So this is what? 2 over 3, then square it because both of them are squared. Then of course I want to transform in such a way that I will have 1 plus, now when you have a root in maths, let us say the third root of a, if you convert this from surd to indices, it becomes a to the power of 1 over 3. If this is n, this is a to the power of 1 over n. So using this principle here, now my solution to this becomes 2 over 3 to the power of 1 over a equal to, then I want to bring this here, so this becomes 2 over 3, remember it is squared, times 1 over a. Now we know in mathematics that multiplication is commutative, so it means that I can say 2 times 1 over a is the same as 1 over a times 2. They are both the same thing, they will give us the same result. It's like saying 2 times 3 gives us 6, and if you bring 3 to the front and say 3 times 2, it still gives you 6. So using that, 1 plus 2 over 3 to the power of 1 over a to be equal to 2 over 3, then I'll bring 1 over a times 2. Permit me to put this in a bracket, in a special bracket. Now, what does this mean? It means that at the end of the day, I can make 2 over 3, I can substitute for 2 over 3 to the power of a because I have it here and I have it here as well. So let v be equals to 2 over 3 to the power of 1 over a. So therefore this becomes 1 plus everything here has become v equals, everything here is v, then squared, v squared. So Rearranging this by bringing everything to this part, it becomes v squared. If v comes here, it turns to negative v. The sign will change. The sign here is positive. If you cross it turns to negative 1 equals to 0. So now I want to use the quadratic formula to solve this. So the quadratic formula says for me to get my v, I will have to use negative b plus or minus square root of b square minus 4ac over 2a. Now, I haven't done that. My a is the leading coefficient here, which is 1. My b is this second, which is minus 1. And my c is this constant here, which is negative 1. So if I substitute them into this formula, that means that my v will become minus times the minus in the formula times the minus here become positive 1 plus or minus b squared means minus 1 squared minus then 4. A is what? 1. Then c is negative 1. Everything over 2a, which is what? 1. So this becomes 1 plus or minus negative 1 times negative 1 gives us positive 1. Then minus times minus gives us plus. Then 4 times 1 is 4. Times 1 again gives us 4. Everything over 2 times 1 is what? 2. So this is now equal to 1 plus or minus 4. 1 plus 4 gives us what? 5 divided by 2. This is our v. Then it then means that the true value for v, right, must be greater than 0. V must be greater than 0. And if v must be greater than 0, it then means that the value we are going to accept for v will be 1 plus root of 5 over 2. Because if you do 1 minus root of 5 over 2, you are going to get a negative value, right? So we are going to pick just this value that is valid, which is 1 plus root of 5 over 2. Now, I'm going to write this somewhere. You know our v is what? 2 over 3 to the power of 1 over a. I'm going to write it somewhere because I need that as we proceed. Now, what do we do from here? Where do we go from here? Now that we know that our v is this, right? So what does that mean? It then means that I will substitute it in the value for v here. So that 1 minus square root of 5, 1 plus square root of 5 over 2 is equal to 2 over 3 to the power of 1 over a. Now, to get this value now, I want to take the ln of both sides. So ln, what? ln 1 plus root of 5 over 2 equals to ln 2 over 3 to the power of 1 over a. Just like log, when you have something like this, log x to the power of a base y, the a will multiply the log of x base y. So I'm going to apply that here. So therefore, I will have something like this. I will have this to be 1 over a ln 2 over 3 equals to ln 1 plus root 5 over 2. Therefore, for me to get my a, I have to divide both sides by ln 2 over 3 and ln 2 over 3. ln 2 over 3 cancels ln 2 over 3. Then I have 1 over a to be equals to ln 1 plus root of 5 over 2 divided by ln 2 over 3. But I want to get the value for a. So what do? I have to take the inverse, meaning take a up, bring 1 down. So what I've done to the left, I must do to the right. That is why they are called equation. Equal means they are equal. What I do to the left, I must do to the right. So if I inverse this and I inverse this to become what is in the numerator will come to the denominator, and the denominator goes to the numerator. So over ln 1 plus root 5 over 2. So let's interpret this. From the laws of logarithm, we know that if we have a common log like this, we have a over b. Okay, let's use x over y. It becomes log x base a minus log y base a, because the both of them share the common base a. Then under division, it becomes subtraction. So I'm going to use the same rule here and here. So therefore, our a will now be ln 2 minus ln 3 over ln 1 plus root of 5 minus ln 2. Now, punching your calculator is 0.69. The value for ln 3 is 1.09. Then the value for ln 1 plus root of 5, 1.17. Therefore, substituting the values that we know, it means that our a will become what? 0.69 minus ln of 3 is 1.09 divided by ln of this is 1.17 minus ln of 2, which is 0.69. This will give us negative 0.4 and this will give us 0.48. So punching it in your calculator, you will get the approximate value of a to be negative 0.8. So this brings us to the end of today's lesson. So kindly subscribe to this channel if you have not done so. Click on the notification icon so that you can see more videos as they drop on this channel. Like this video and share amongst your friends. Thank you and goodbye.